Here's another volume question, area and volume question. This is from the 2021 instance of the exam, number 3. No calculator is allowed for this one. Okay, so a company designs spinning toys using the family of functions this guy, where c is the positive constant. Figure above shows the region in the first quadrant bounded by the x-axis and the graph of this guy for some c. Each spinning toy is in the shape of the solid generated when such a region is revolved about the x-axis. Both x and y are measured in inches. Okay, part A, find the area of the region in the first quadrant bounded by the x-axis and the graph of y equals that guy, for c is equal to 6, okay? So we just want the area under the curve, under this curve, which is c equals 6, so 6x squared or 4 minus x squared. Okay, so that is basically our setup, but we need limits of integration. So we got to solve for when the function equals 0, so that's when x is 0, or that's when 4 minus x squared equals 0, so x can be plus or minus 2, we're in quadrant 1, so we just take the positive, okay? And so the area is integral from 0 to 2, start to stop, 0 to 2, that's what we found, 6x squared or 4 minus x squared dx. Now we can solve this via a substitution. U is 4 minus x squared, du is minus 2x dx, okay? So this becomes square root of u, 6x dx. We can rewrite this third line as minus 3 du is 6x dx. So replace those two with minus 3 du. Minus 3 is the constant. I pulled out in front. This is a definite integral, so we got to change the limits of integration as well. Lots of pieces here. When x equals 0, u is 4 minus 0, which is 4. When x equals 2, u is 4 minus 2 squared, which is 0. Okay? Now, we can use properties of integrals where we can flip the limits and add a negative sign, which there's already a negative there, so it becomes positive, okay? This is just power rule, fundamental theorem calculus. Don't forget your units, it's inches squared. Okay, so let's look at the scoring guidelines. Honestly, I would stop at this line, so that's why I wrote it here. You don't need to simplify. If you want to, it's risky, but this one's not bad. It's 16 inches squared. You'll see in the different parts, much riskier. This one's not bad at all, so 16 inches squared. So what are the points? 1 point for the integrand, right here. I'm surprised that they didn't require, there's no points for the limits of integration, unless that's part of the 1 point, okay? Antiderivative, that's 1 point. Answer is 1 point. Do you need the units? Let's see. Units are not required for any points in this question and are not read or presented. Okay, so I guess you don't need the units, but there it is. Okay, so I'm confused why they gave that then, if you don't care about it. All right, part B. It is known that for this function dy dx is this guy. For a particular spinning toy, the radius of the largest cross-sectional circular slice is 1.2 inches. What is the value of c for this spinning toy? Ooh. This is not a typical question. So did we get stuck? Did we give up? Let's think it through. For a particular spinning toy, the radius of the largest cross-sectional circular area is 1.2 inches. So we can even look at this. So this is probably the largest radius over here, right? Because when you rotate it, this function is the radius. Does that kind of give a hint now as to what to do? We gotta optimize, min-max. The largest radius occurs at the maximum of this function. And when do max min occur? When the derivative is 0, and specifically it changes sign, which it does there, because the derivative is positive, negative, okay? Did you get that concept here? So, we're going to set this equal to 0 to find out where the max slash min, or in this case, the max, occurs. Set this equal to 0. That's right there, okay? So we start solving for x, multiply both sides by this square root, it'll be 0 on this side, right? Divide by c, it'll go away because of the 0, so 4 minus 2x squared is 0. X squared is 2, okay? So x is plus or minus square root 2, we're in quadrant 1, so just keep the positive. So we know the max occurs at x's square root of 2. Okay, so we're going to use this piece of information now to find c. The max value is 1.2. So 1.2 equals, we just found that the max occurs at x is square root 2. We plug that in right there. And we solve for c. C is 1.2/2. I would just stop there, honestly. Or you can simplify to 0.6. Okay, scoring guidelines. Let's see what gets the points. This gets you 1 point. And 0.6 gives you 1 point. Okay? For another spinning toy, the volume is 2 pi cubic inches. What is the value of C for the spinning toy? Okay, so we gotta use the disk method. I was thinking washer, but it's not a washer. So I was thinking, what's the simpler case? The disk method here. Okay, so we set up the integral. We already found that the limits of integration was 0 from 2 from part A, so I don't think we need to show that again. So we know that volume is 2 pi equals pi r squared dx. So pi r squared, the radius is the function itself, squared dx, and the limits of integration are 0 to 2. Okay, so we start solving for C. Okay, so what did I do first? The C squared is a constant, or I guess from here I squared everything first. Okay, C squared is a constant. I pulled it out in front of the integral. I divided by pi as well on both sides, so these go away. Okay, here, and then I distribute this x squared to both terms. And then power rule, fundamental theory of calculus. So here's the risky part. After you do fundamental theory of calculus, don't bother simplifying. It's way too risky. So just do C equals square root of 2 divided by this whole thing. This you can combine to 32/3 minus 32/5. That's simple enough. I would do that. Okay, but stop here. Don't bother simplifying. Way too risky. Not worth losing the point for simplifying incorrectly, because I don't think they give partial credit for wrong simplification. It's all or nothing. Okay, so leave it like this. All right, and that's it for this problem. This is not bad at all if we understood this concept over here, that we were maximizing. So we want the derivative to be 0. Otherwise, this was pretty straightforward area, and this one's pretty straightforward for volume as well. Okay, hopefully this is helpful. Please give this video a like if it has helped you in any way, and hopefully I see you in another video as well. Bye.